Welcome back. In this video, we are going to solve problem 10-89 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the gas tank has inner diameter of 1.50 meter and wall thickness of 25 millimeter. If it is made from A36 steel and the tank is pressured to 5 megapascal, determine the factor of safety against yielding using the maximum shear stress theory, and B is maximum distortion energy theory. So you can see this is the figure, that is a tank in which there is a pressure of 5 megapascal, the inner diameter is 1.50 and the wall thickness is 25 millimeter. So let's start with the solutions. First we will check whether it is thin wall pressure vessel or not. So for that we can write, since R by T is greater than 10, so it will be thin wall pressure vessel, and we can use its formula. Okay, so R is diameter is given, since DI is given as 1.50 meter. So from here we can see that radius will be equal to DI divided by 2 is 1.50 divided by 2 is 0.75 millimeter, and thickness is given as 25 millimeter. So 25 millimeter is actually 25 divided by 1000 meter, and that will be equal to 0.025 meter. Now you have both the value, so you can just find R by T. So R by T is 0.75 divided by T is 0.025. So I will calculate it, 0.75 divided by 0.025, and you can see that is equal to 30. Okay, as R by T, which is 30, and that is greater than 10, so it is thin walled pressure vessel. And we know that formula for thin wall pressure vessel is, we have hoop stress, which is sigma h, and that sigma h is the maximum stress. That is, we can also say this is one of the principal stresses. And then the formula is PR divided by T. And tangential or longitudinal stress, the second stress is longitudinal stress, which is represented as sigma T, and that is equal to sigma 2, which is PR divided by 2T. And we know that sigma H is greater than sigma T. Why? Because we can see that sigma hoop stress is always equal to half of tangential stress. Tangential stress is half of hoop stress. I will also show you half of hoop stress, because we know that hoop stress is PR divided by T, PR divided by T, and we have 2. So it means that you can see this value is tangential stress, PR divided by 2T. So sigma tangential is half of hoop stress. Okay, now we have this sigma 1 and sigma 2. So first we will find factor of safety using maximum shear stress theory. As we know that sigma 1 and sigma 2, they are both positive, they are having same sign and sigma 1 is greater than sigma 2. So according to that, we have this allowable shear stress will be equal to sigma 1. Sorry, allowable, since we sigma 1 is greater than sigma 2, it means that allowable normal stress will be equal to sigma 1, and that is equal to, how we will find this? We have sigma 1 is this formula, so PR divided by T. So put the value, P is how much? That is 5 megapascal, and T is 0.025 divided by T. T is 0.025. Okay, so we will calculate it. 5 multiplied by 0.025 divide by, sorry, R is 0.75. Okay, so I have to 0.75. So 5 multiplied by 0.75 divide by 0.025, and we can see that allowable stress is sigma 1, which is equal to 150 megapascal. Okay, now using maximum shear stress theory, so what we are going to do is that factor of safety will be equal to yield stress divided by allowable stress. What is the yield stress? So for A36, I have to go to the end of the book properties table, and you can see that average mechanical property, and unit should be SI. So here you can see I will take the first one is A36, so 250 megapascal. The unit will be 250 megapascal. So I will write it, sigma yield is 250 megapascal, and we will get factor of safety will be equal to 250 divided by allowable is 150. So 250 divided by 150 will give you 1.666, or you can say that factor of safety is equal to 1.67 using maximum shear stress theory or MSS theory. Now for part B, using maximum distortion energy theory, we know that is equal to sigma 1 square minus sigma 1 into sigma 2 plus sigma 2 square is equal to allowable square. We have sigma 1, so we will find sigma 2, and we know that sigma 2 is equal to half of sigma 1, because you can see sigma 1 is PR divided by 2 and sigma 2 is PR divided by 2T. So 150 divided by 2 will be equal to 75 megapascal. So we will put the value 150 square minus 150 into 75 plus 75 square will be equal to sigma allowable square. So we will calculate that 150 square plus 75 square minus 150 into 75 will become equal to this. So sigma allowable square is 16875, and allowable stress will be equal to under root 16875. So taking the square root of answer is 129 point. Sigma allowable is 129.9 megapascal. Okay, you have this, and we will find factor of safety is equal to yield stress divided by allowable stress, and that is equal to sigma yield is 250 megapascal and allowable is 129.9 megapascal. So 250 divided by 129.9 will give you 1.92. Okay, so I will write factor of safety is 1.92 using maximum distortion energy theory, or using von Mises criteria. So this was all about this problem 10-89. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.